Today we're going to talk about SQL. What does SQL stand for? Does anybody know? Structured Query Language, right. What I'd like to do today is on your Slack, there's actually these three files here. If you want to play along, you could get all the files into the same folder. The most important file is the one that ends in .db. That extension is a database file. You could think of a database file as kind of like an encrypted text file. Like as a human, I can't really read what's going on in here. Right? This file is not displayed in the editor because it's either binary or uses an unsupported text encoding. Do I want to open it anyway? I mean, I could. I can see some info in here, right? But it's not really formatted in a way that's super useful to me. I can see like a lot of words, but I kind of would rather have this be managed in some other way, right? So we have these tools, like SQL servers, we could call them, or databases rather. And a database is both the thing that holds on to these DB files and also like the mechanism through which we can make queries about the data in the database. There's 4 types of queries that we can make to a database. There is a create kind of query, right? So assuming that information is already created and put into a database, I could say like, let's add some more, right? We've got a table, let's put another row in the table. So I might say like, let's do an insert and let's pop into a table with some more information. The second way that we can do a query in SQL into a database is to read, right? So we could say, basically, there's some information, there's 10 rows in a given table. I'd love to see all the information about all those rows. Could you return them to me so I can read that information back, right? Or hey, I want to search for a single record. That's a type of read too, because what happens is a single record comes back, and then I can see it, read it, and understand that I've got what I'm looking for. The third kind of thing I can do is update. I can take a row out of a database, make a change to it, and then make sure that that row is saved, like when it gets put back in the database. And then finally, there's deletion, right, where I can make a row or a table like just kind of go bye-bye. Those are really the 4 things that we can do with data, right? We can add it, we can edit it, we can delete it, or we can just simply take a look. So today, we've got a bunch of queries to run on this database. There is a DB browser. Does everybody have DB browser installed? Do people not have DB browser installed? There's this program called DB browser. I think that people should get it installed. Check this out. If you search like DB browser for SQLite, it's SQLitebrowser.org. SQLite, by the way, there's like different ways that people handle databases that you talk to with a structured query language. So one way is that you have a database that like sits on a server and you need to actually make a call to the database like as a user with a password to a specific port and address to access that data. And then that lets you like distribute the database and like work with it remotely and stuff. This is a light version of that, right? There's not a server living somewhere else. This is just a flavor of SQL that's designed to be like living and runnable within your own machine. Right where you're at. So it's really good for like practicing stuff and building like an app that you can develop on locally. That also means that when you do Googling around SQL, you should probably specify SQLite, right? Because there's different flavors of SQL. There's like SQL Server and there's like MySQL and there's other stuff. So different syntaxes for the same kind of stuff exist in different flavors of SQL. So you should specify SQLite when we do stuff. When we get this DB browser open, it looks kind of like this. You end up with like a window, and it's a nice visual way. You've seen in the labs yesterday that like you can definitely interact with databases in the terminal, but sometimes that's a little clunky, right? Like I don't really know what folder I'm personally in when I start creating files, so then I get crossed up. The database SQL sometimes is hard to like get into the file and then get the file fed into the database correctly with the terminal command. Sometimes I don't even like get the syntax right, like when I'm trying to type it out in the actual SQLite terminal, and then I feel like I have to like push up a bunch of times or manually edit a really long line. It's not the best like way, not the cleanest way for me to just do SQL if my focus is practicing as many queries in as short a time as possible. So today I want to really practice query stuff with SQL. So for the next like 40 minutes or so, I'm going to use this DB browser with some prompts from this README to do some things with this data. And the reason for this is that I'm interested in music. I've been playing music most of my life. I'm going to go here, open database, and then I'll find desktop, Flatiron School, Chicago Web, Intro SQL, our database. Cool. So once you find the DB folder or file and you open it here, then we've got it. I've been like really into music, and I'd like to make an app where like people can become like fans of artists. So I've arranged some SQL queries that are around me making sure that I know how I would work with data, right? By the way, why would we be talking about data? Like, why do we care about databases in general? Like, I know that like we care about it because there's labs that aren't finished, and we're here to like finish labs. So like on a process level, we care about them in the short term. But what's the overall context? Ethan.
The idea of persistence, like if you have an app where users are interacting with it, you want to be able to like store information after that.
That's right, absolutely. Like you go into your Ruby app and you make sure that you can create an object, like you do like add tweet or something like that, a new tweet gets created. But then the next time you run the app, you'd have to run add tweet again to like get that same tweet created, because it's not like the tweet sticks around, right? The app closes, Ruby goes away, that memory is not being used anymore. This, because we have a new DB file now that contains that text that we just looked at, if we can find ways today to make changes to a file like that through Ruby, then we're going to be in really good shape with our code. But first we need to understand just how that data gets talked to, and that's what the morning's focus is. So we've got this browser. In this browser we have like 4 main tabs to do stuff. Edit pragmas, I'm not really playing with today. Like pragma stuff is not my main focus. Today the focus is trying to figure out how objects relate to tables. And so we're gonna mainly talk about how tables are related to one another in databases this morning. So execute SQL, I can put in a SQL command here and it's gonna try to do something. So if I said something like insert into cats, a cat, this probably is not valid SQL. And then I click on the play button, and yeah, it says syntax error. It does not like a cat, like what I tried to insert into cats. Also, there's probably no table cats, but this is just to showcase that like I can definitely like type SQL in here, and I can get some feedback based on what happens. This first tab is really nice. Database structure kind of shows me a look of like what's happening in this database. There's 6 tables here, called albums, artists, genres, and tracks, and then there's 2 more that are about kind of like SQLite managing its own stuff. I don't really need to worry about these. These are more like admin stuff that's just there to like dot I's and cross T's and help with like cleanup on database operations internally. But these other tables were all created. It even shows in the schema like the exact command that was used to create the table originally. That's kind of a helpful feature. If we drill down into albums, we can also see here how each of the fields within the table was created. And now that they've been created, we can see what type each field is. So when we think about instance variables on objects, right? We might think about a cat having like a has clause as a Boolean and having age as an integer, right? And having a name as a string. And if we wanted to translate that and have a table called cats, we might just do the same kind of thing here. But we'd say like name, string, age, integer, has clause, Boolean. This is what's happening right now, right? We've got title varchar. That's just another way to say a string, essentially. Varchar is, you can look it up and see like exactly how it's configurable, but it's about like having a set number of a couple hundred characters max usually that holds on to some text there. There's other kinds of types that you can apply if you want to hold like much longer strings and stuff, but varchar is one that we talk about when we're talking about strings. We have an artist table. It's also got a name. What do all these tables seem to have in common? Well, except for the meta ones. What's common between albums, artists, genres, and tracks? ID. So what's the purpose of ID on these? Does that identify the table? What's going on there, Ellis? Very good. So the scope of ID is none of this stuff is table scoped, right? We have a name of a table, and then each of these things are going to be attributes that apply to each row in the table. And so when you have an ID, that row is going to be numbered, right? And we have some special things going on with these IDs. We have this thing that says primary key auto increment. So it's not just numbered, but like primary key means SQL is going to try to like use that as the main way that we look up a given album when it's stored in the database. And auto increment means that it's going to start with 1, and then it's going to move and name the next one 2, and the next one 3, and the next one 4. But then if I delete all 4 of those albums from the database and I add another one, the ID is going to be 5, not 1 again. So auto increment is SQL's way of keeping track of what IDs it's assigned for a given table as long as that table has existed. And that makes sure that that ID doesn't get reused later on. That would be a catastrophe, right? Imagine logging in and creating an account at a bank. And what they do is they assign you the ID of somebody who quit their bank account that had like a negative $4,000 balance. And now that's your balance because they've assigned that person's ID back to you. You'd never want to do that. And so we understand that with data, like when we assign an ID to something, it's supposed to be for that thing, not for something else that happens to come in the same ordinality when we create items. So that's what auto incrementing is for. But these all do have IDs. What do you suppose track's genre ID corresponds to in this database? Very good. So I heard 3 pieces of information there that I like. I heard genres, right? Naming the table specifically. Then ID, naming a specific field in the table. And I think you nailed the description of the relationship. This is what we call a foreign key because it's designed to match up with the primary key in some other table than this one. So the tracks table knows that there's a genres table out there. It knows that this ID should correspond to the primary key ID of one row in that genres table. Therefore, we don't need to write down like a genre name right here on track, right? We can just write the genre ID, and through that information, we could find the matching genre, and then we could pull that genre's name, right? Doesn't seem to save us a lot of steps in this way, right? But if we have an album ID, right, the album also belongs to an artist, so now from a track, I could find my way back to the album that that track belonged to, and then I could also find my way from that album to the artist who had written that album. So therefore, from a track, I could find the artist who is associated with that track just by following those foreign keys. That's the main thing I want to look at just for a second before we hop into writing some real queries here. So thanks for bearing with me as we get the overview. Browse data on this second tab, by the way, is a way that I can check outputs later on against the stuff that's really in the database, so I can make sure that I'm on the right track. This shows each ID, title, and artist for an album. So all those column names are now at the top, showing up on columns, and I can kind of see how this data is living in the database in a table type format. Genres just has an ID and name. We have some rock, some jazz, reggae, pop, etc. Various tracks, composers listed, and then we have these IDs listed there. So that's how the information actually looks outside from just the plan or the schema. Cool. So let's get in practice a little bit. Let's start with pretty simple queries. Write the SQL to return all of the rows in the artist table. This is what we'd call a read operation, by the way, right? We're not trying to add anything or change any data that's already there. We just want to see some stuff. So what's a query to return all of the rows in the artist table?
Select star.
Okay. Select star.
From.
Select.
And then the name of the database.
So artists.
Artist, correct.
Select star from artists. Let's do this. Cool. So why did it return ID name? What made it return ID and name?
You put all.
Star, yeah, star means all, right? Star means give me every single column that exists in the table or tables that we're focusing on. So if I wanted to figure out what columns I could use in another query, I could start by saying select star, right? If I woke up in a dark room and somebody just said, there's a database here, figure it out. Here's the table names. Well, what kind of stuff does an artist have? You got to figure that out. I could start by saying select star from artists, and then I could scope and go, yes, an artist has an ID and a name. That can help me to point my query in the right direction later. Cool. So that's a nice little warm up. Select star from artists. Let's move to the next one. Oh dear. Scrolled all the way down. We'll write these in as we do them. Write the SQL to select the artist with the name Black Sabbath. Okay. So we have select, which we just used to figure out what fields do we want to see, and then we have the from keyword that told us what tables we want to see those fields from. What can we add to this to restrict the search to just be about artists named Black Sabbath? Where, right? So where basically lets us pass in kind of a key value, right? And we can pass in multiples chained with and, or we can just pass in one. And the way it's going to work is we'll name the key. So I think it's going to be name. And then we'll use an equals. And then we'll pass in the value that we care about, which should be Black Sabbath. Hit play on this. there's our artist. It's got ID 12, right? So that tells me I could also have said where ID equals 12, but that's kind of a convoluted way to search for an artist with the name Black Sabbath. I'm not sure if the user would have had the ID in their head as easily as they would have had the name. But that same search, right, returns the same result because those are our two attributes on that particular artist. So I'll go back to this first one where name is Black Sabbath, make sure that my casing is correct and it still works. Because if I'm going to copy it, I want to make sure I copy what's right. Cool, we'll come back over here. Write the SQL to create a table named fans with an auto-incrementing ID that's a primary key and a name field that's text. So we need to create a table called fans. Because my goal is like Black Sabbath should have fans, Black Eyed Peas should have fans, everybody deserves fans. So let's see, I could say SQLite create table. SQLite create table with examples. That's SQLite tutorial. Create table if not exists. Oh, so this in the brackets here when you read this stuff, generally this will show me like where the argument comes in if I want to use it, right? I don't necessarily need to say if not exists. I could say create table and then schema name dot table name. So I don't need to specify which schema I'm operating in, but it does look like the table name is going to be mandatory. So I'll probably say create table fans, and then it says here column 1 data type primary key. So that's probably going to be like ID integer primary key, right? Let's try this out. Zoom back out. Create table fans. Run it back. And it looks like we open a parenthesis here. And this will support a multi-line query. Maybe I should have this like close up at the end. Because yeah, there's closes at the end. Without row ID, that's another optional thing. So I'm just going to do a semicolon here. And I'll say ID primary key. But they said auto increment too. So now I'm kind of like, I feel like we're going to miss a step. Primary key. So what I could do is like hop back to this database structure and figure out exactly how they created their integer primary keys. Notice that this like ticks around a field name seemed to be optional. Like when they did albums, they used a string, but when they talked about artists, they didn't use a string. I think they're trying to showcase that there's like interchangeable ways that we can use this syntax. But I think this is the main thing. Primary key is 2 words, auto increment is 1 word. So it's going to be ID integer primary key auto increment. We can do that. ID, make this lowercase, integer, primary key, auto increment. And then according to the syntax here, we just put commas in between these, right? So then there needs to be a name, which is going to be text. So I'll say name varchar. Let's see what that does. Hit play. Result, query executed successfully. And then if we go back to database structure, hey, check it out. Create table fans. We can look here, and then we have a table fans that has the ID primary key, and it's got a name. So we successfully created our table. That looks solid. Cool. We're still not at the fun part yet, by the way. The fun part for me is where we get to join data together. That's why I think databases are cool. I don't think any of this stuff is better or easier than just writing a thing down in a document. The magic of SQL is when these tables actually do start relating together and we can start getting meaningful, complex data back about relationships. But first, this was create, right? This wasn't a read, we actually did some sort of create type of thing, right? We didn't add data, but we added a place to store data. Okay, alter the fans table to have an artist ID column type integer. That makes sense, right? If I'm gonna be a fan, I should be a fan of an artist. I could think of this relationship as a one-to-many, right? An artist has many fans, but a fan belongs to one artist, right? We could even call that like a stan more than a fan because it's like they're so devoted. Yeah, cool. So how do I add a column to a table? SQLite, let's try this, add column. Rename column, cheat sheet, add a new column to a table. Alter table, table, add column, column definition. Or add column definition. I don't know what column definition means. I'm guessing that it might be though, like where we have to say the name of the column and then the type again. SQLite, add column. Alter table. Alter table, table name, add new column name, column definition. What is column definition? Yeah, just the data type and definition of the column. Add status varchar. Okay, that makes sense. So I think it's going to be something like alter table fans instead of create table. And then the syntax here was just the word add. And then we'll say artist ID. And that's going to be an integer. Let's see if we got that right. Syntax error. Maybe there's no, oh yeah, there's no parenthesis. So my copy pasting was too aggressive. That looks better. Query executed successfully. Database structure. Hey, there's our artist ID, integer. Great, cool. So let's bring that back and save that for the history books. All right. Write the SQL to add yourself as a fan of the Black Eyed Peas. They tell us here that artist ID is 169 for the Black Eyed Peas. If I'm not sure about that, I could always come here to browse, go to artists, scroll down, scroll down, scroll down. There they are. Yep, 169 Black Eyed Peas. Cool. So I need to add myself as a fan. What does that mean for the database specifically? What change needs to happen to the database to add a fan of the Black Eyed Peas? Yeah. Yeah, so we need to think about how the fans table is going to change, right? How many rows currently exist in that table? We don't have any rows right now, right? We have name, we have artist ID, those are column names, right? We know what row data will be stored when we store a row, but we haven't put any in. What we need to do now is insert a new row into the fans database, right? In Ruby land, we'd say, oh, we need to instantiate a new instance of fan. So like the comparison here is we're not like instantiating an object, we're adding a row to a database. That's how things come to be in database land. So let's talk about how to insert a row. SQLite insert row. Insert into, okay. So it's insert into, and then we name the table, and then in parentheses we put the order of the columns that we're gonna set. Then we say values, and in another set of parentheses, we match up the column order with the values in that same order. So insert into table, so that's gonna be fans for the table. Oh dear, there we go. Bring it back. Say insert into fans. Fans is gonna be the table name, so that's lowercase. Then in parentheses, we have like column 1, column 2. I think it's gonna be name, and then the artist that we're a fan of, so artist ID. And then we have the values keyword and provide a name, which will be Duke for me. If you're playing along at home, you can feel free to use your own name. It's your database, your world. All right. It's Bob Rossing the shit out of everything. Okay. It says query executed successfully when I ran this. So let's go back to browse data now instead of database structure. I want to see what data is really there. If you go to fans, hey, check it out. We got name Duke, artist ID 169. So this insert into worked. We had to set the table, then we had to name the columns that we were trying to set. I bet if I had a typo in the column name, that probably wouldn't have worked. It would have said like, hey, there's an error here. We could try to insert another Duke. There's no like uniqueness. So what if I took out the underscore in artist ID? Yeah, then it's red. Table fans has no column named artisted. So that's fine. It'll guide me down the right path. Sweet. Let's bring this back. Okay, here's a fun little pause, like just to like freshen us up. There's a cool thing to do when we talk about data in databases. A lot of times we want to store a database with a lot of data, right? If I'm making like a game, an app about tracking who has won phase 10 games in a given family, or like a household where you play a lot of a single game and you want to track that, I'd probably want to store a lot of records of a lot of games and like a lot of players. So it would feel like there was this living world of a lot of people coming through and not just like 2 or 3 sample things, or 3 or 4 things in a list. But I also don't want to type out every single name that I can think of because that's tedious. And so we have this gem called Faker. And Faker is designed for like situations where you need to seed a database with some piece of data or some pieces of data, but you're not particularly concerned with like coming up with exact data on your own, and just having randomized values would be okay. So this Faker gem here generates fake data like names, addresses, and phone numbers. And basically, You install it by just writing gem install faker, like into your terminal. Gem install faker. Boopity boop, does some stuff, goes and gets the gem and installs it. You can do this on your computer if you want. If you get this problem, then they have this like other issue. You can go to their GitHub and try this to get their specific version of faker. But then for usage, all you have to do is require the gem in like an IRB or a pry session. So I'm gonna hop into IRB, require the faker gem. It says true. So then you have faker, and then you have all these subclasses under faker. So this is something that kind of helps us out if we think about some of the class name and class variable syntax that we've seen so far. This tells us that there is a class called name that lives inside of a class called faker, and you can access subclasses the same way that you'd access a constant inside of a class with this double colon notation. I'm gonna make this a little bit bigger. So here they have faker name.name. Faker name.unique.name, make sure that it never repeats a name. I don't really care about that. I'm just going to try this faker name.name thing out. Faker name.name. Francesca Ryan Sr., great. Miss Ariane Tremblay. Meta Hackett, that's me.
This explains like those fake emails I get all the time. I actually started a list of all the names from fake emails. They're such good names.
Yeah.
Like screenplays and stuff.
Yeah.
Like that. Like, these names are amazing.
They're amazing. If I was ever in roller derby, this would be my roller derby name. 100%. 100%. Not even, just not a hint of irony in that. All right, so we've done this. We required faker. We generated a fake name for ourselves. So now I want to update my name in the fans table, right? So updating an existing piece of info is going to be a lot like inserting info, right? Because if I'm going to update info, I need to decide what I'm going to update, and then I need to provide values so SQL knows how I'm going to update it. But with update, unlike insert, the thing is already there that needs to be updated. So we need to provide more information to talk about the specific row that needs to be changed. So SQLite update row. SQLite update statement. Update table, and then we say set column 1 equals new value, column 2 equals new value, where, and then there's some sort of a search condition, right? Because we don't want to just update everything with this certain key and value. If we leave the where off of an update, it's still syntactically correct, but the update that you decide is going to apply to every single row in the table. So like, I don't want to name every single fan to be Meta Hackett, right? That would be a good calling card if I was actually like a meta hacker. That would be exactly on brand, but not my intention. I'd only want to name myself this, right? So I'm going to probably say I need to update the fans table and set the name to equal this faker name that's on my clipboard. And I need to do that where some condition that finds me as a fan, right? So let's look at the conditions that define me as a fan right now. I am fan ID 1, name Duke, artist ID 169. Okay, we'll come back to that in a second. We'll say update, then just the table name, update fans, check back to the docs, set column 1 equals new value 1, set name to equal Meta Hackett. I already had the string. I didn't need the extra quote character. Cool. And then we need to say where. And let's think about what condition we use for the where real quick. What if I said set name to equal Meta Hackett where artist ID equals 169? Would that change my name?
Yeah, but also
Yeah, what if there were more fans of the Black Eyed Peas? Imagine a world where there's more than one, just for a second, all right? And I don't want to change all of their names at the same time, right? So like, I wouldn't want to use that as my condition. Could I use where name equals Duke as a condition? As long as I'm the only Duke, right? So if the fans database had a uniqueness restriction on name, like if it was impossible for any duplicate Dukes to be stored, then that would be a safe condition for me to use. I could say, let's change the name where name equals Duke, and we'd be in good shape. What's probably the safest one though? Yeah, so now my name is Meta Hackett. Let's say I want to change it back to Duke again, right? Because that first query executed just fine. But let's say where ID equals 1. Like the whole point of having that primary key be auto-incrementing is it's like a fingerprint for that row. Like it's unique every time. It's not like sitting on some old data anytime. Now I can come back. Oh, did I get the SQL executed? Oh no, I didn't change my name value. Should be Duke. Oh, well, the synthesis. Where ID equals 1. Semicolon, play, go to our data, and then we're back to being Duke. So I think that generally if we're going to do an update, you'd want to use the ID. Because yeah, it can be too much of a headache to always try to manually remember like, oh, is this one of those databases where I have uniqueness on name? Or is this like not like my last project where I put uniqueness on name? That's like, you shouldn't have to actively remember like that to do work. We should have some like other convention that keeps us from having to make a choice like that every time. And ID is that convention for us. Cool, so how do I return fans that are not fans of the Black Eyed Peas? I guess I should put a fan in that's not a fan of the Black Eyed Peas. Hang on a second. Let's put in a couple. Let's say that there's Ben, who's a fan of whoever 160 is. And let's say that, oh, I felt like that was a sound effect for adding Ben. That was fun. And let's say that Libby is also not a fan of the Black Eyed Peas. Cool. So now when we look at the table, there's 3 people with different fandoms, right? So now we need to find a way to just return me, just to not return me, but to return everybody else. So how do I get fans that are not fans of the Black Eyed Peas out? This last one was an update, by the way. This is going to be a read again. So if I'm trying to read, what's the word bin for every read query that we've done? Select, right? We're trying to ask the database, show me something. I want to see some fans, so I want to select them. And what are we going to select? All the info? Probably. Why not? If it didn't specify specific columns, I'm not going to worry about it. I'll just use a star. And this will come from the fans table. So what's the condition that I want to search for a fan that it's not a fan of the Black Eyed Peas? Not equal to Duke? That, I think that's even better, right? Because right now I happen to be a fan of the Black Eyed Peas, but if I changed my fan alliance, the name of Duke isn't going to be the right condition anymore. But Black Eyed Peas, as long as they are artist 169, artist ID 169 on the fans table is pointing to them, and those are not the fans that I want right now. So I could say like where artist ID is not equal to 169. Give that a shot. There we go. There's Ben and Libby, but not me. So that's how we can use a where query like with a negative condition instead of a positive condition. That's kind of cool. I'm very excited now because now we get into the fun part. And now I'm going to take like a pause as we think about this because it's going to require you to do kind of something that I've been doing already. What you've seen me do is see that I need to do a thing. I go to Google, like search for how to do it in SQLite. I find some instructions. I try to cobble together based on the instructions what I need to do based on the context of my info. Given that, I'd like you to either on your own computer or get next to somebody who's got it open and like has some thought on something that they could type up. Write the SQL to display an artist name next to their album title. Show of hands, who has this database open in their DB browser right now? Cool, cool. If you do not, find somebody that just put their hands up and pair up. We'll try to figure out how do we display an artist name next to their album title. The output should only display those 2 columns and nothing else.
Off the bat, it kind of sounds like
So you're like, you're joining the tables and you're saying the artist
Yeah, so
ID
here,
in your
actually, this is-
equivalent.
because it's artist and album, it's a different
What's the new keyword that people are toying with right now as you work? Join, sure. Join, inner join. Inner join will work. Join will work just the same too. If you're using join and stressing about what's inner join, don't worry about it for now. Join will work too.
artist to their album. Now when it comes to from, we're grabbing this data from the same standard. Okay. Oh, data. Okay. What version did you download?
Oh, maybe? I wonder if we do that. I wonder if we should go AC/DC every album, next artist every album.
We'll take about 3 more minutes.
Is it the artist name next to the album cover? Okay. Where artist or name? Just do artist equals Black Eyed Peas.
Yeah.
Oh shit. I don't know if how they
is there a, let me see.
I don't want to do the regular way of the sales things. I guess I have to like do this manually.
Let's see here. There is a Linux distribution for DB browser. There's a, if you go to the downloads tab on the SQLitebrowser.org page, down below Mac OS and nightly builds, it says it works well on Linux. What's the version for Linux? Oh, here it is, yeah. It's like
Oh, from or where? Yeah, 'cause I guess it's been the same location.
actually it might be
Or at the end of the on state.
apt-get. It should be on the page. Yeah.
I just want to know, like,
So I do that for the
Oh, you're right.
is the join correctly? I think. I'm hoping.
For sure.
Yeah.
All right, y'all. I'm gonna try this out too. We need to display an artist name next to their album name. So when I think about how to display an artist name next to their album name, honestly, the first thing I do is I look at the database structure, and I want to look at like what the artist table has and what the album table has, because I need to figure out how to display those things at the same exact time. So what connective tissue do we see between albums and artists? Yeah, we have this foreign key of artist's ID on the album's table, which points to, or should point to, the primary key on the artist table, right? Based on how the name of the foreign key is set up, I would be inclined to believe that if artist ID was on a given album row of 4, then when I went to artist 4, I would find the artist who wrote that album. Given that, let's look at the actual data in the albums and see if we can like make that connection with our eyeballs. So I'm gonna go to the albums table here. I know that Jagged Little Pill is an Alanis Morissette album, right? I know that like I know my daughter's face, right? So artist ID is 4, right? So I'm gonna go to artist and look at the ID of 4, and hey, there's Alanis Morissette. So that's like that's the connective tissue that we're talking about. Let's do it with another one. Maybe one that I don't know right off the top of my head. Well, you know, Supernatural, right? If you're a youth group kid, that could be DC Talk. I'm thinking it's Carlos Santana, but it could be DC Talk, right? Let's play that classic bar game, Santana or DC Talk. All right, we'll go here to artists and find what artist 59 is. Yeah, it's Santana. I didn't think it was going to be DC Talk. It's kind of a niche thing to be into in high school. Cool. So yeah, we've got that connection, right? So wherever the artist ID field lines up, we're gonna have that artist with that ID able to kind of fill into that slot. Yeah.
Like, how would they have effectively made an artist ID section though? Like, because that seems like a lot of work to like match those up. Like,
Yeah, they did a lot of work. That was basically it. Oh, I'm thinking that there's a couple of ways that you could have done this, right? You could have had a whole like CSV file where like every album actually had the artist name, like instead of the artist ID, and then as you put it into the database, you have some sort of code running that says like, hey, if you look up, let's find the artist name field for this album as we write it into the database. Let's look through our artist table. If we don't have an artist with that name, let's add one and use that artist ID and then plug in the ID instead. If an artist with that name already exists in the database, let's pull the ID from that and plug in that in the artist ID field. And yeah, in fact, by the end of tomorrow, we're gonna have a tool that does those kind of things for us when we like put records into a database, and it's kind of a beautiful thing. But yeah, that's the main question that we should be thinking about, right? Is like, how, if we started with artists and albums, right? If I had, let's see, it looks like an album would have an artist ID. So then an album in Ruby might have a whole artist object, right? And you could think of that artist object as having an instance variable ID and an instance variable name. So maybe the process of like translating the Ruby object to the database, they called artist.id on that like instance variable in the album, and then that got set to the database table for that album's row. Yeah, that's another way to model it. I think that's kind of close to what we're kind of getting at as far as the relationship between Ruby and our database stuff. So that's the connection. We have this keyword join, or also inner join. Whether you use like inner join or outer join or left join or right join, that's going to affect what records are not part of what matches together that still comes back in the response. So sometimes you want to get all the info from all the rows back in the response. Sometimes you only want to get the intersection. Sometimes you only want to get the intersection and the associated info from the first table. Sometimes you only want to get the intersection and the associated info from the last table that's not part of the intersection. I'm not really going to get super deep into that. The thing I want us focusing on is this connection, that the album has an artist ID foreign key, which corresponds to the primary key ID on the artist table. So knowing that, if we need to get album titles and artist names, what are we gonna do? I think it's, we're getting it, so it's a read, right? So our verb is gonna need to be select at the start. And then how are we gonna specify that we only want the album title and the artist name to show up? Yeah, we could use that as arguments for select, right? If I wanted to get everything back, I could say star right now. But I don't necessarily want to get IDs, right? I just want to get names and titles. So I need to name the table that has the thing that I want, and then I need to name the field. I can say albums.title. I can say artists.name. I can comma separate them. And then, now that we know what we're looking for, right, I've named fields from 2 different tables now. So SQL will break if I try this query and I haven't told it how those 2 tables come into play. So now my goal is to mention both of those tables, right, but also to mention them in a way that SQL knows the connection the same way that I do. Because when I just looked at album and I looked at artist ID, in my head, I was really thinking about the artist primary key that I would have to look up. And I need to put that into SQL's head too. And the word that we'll use for that is join. So first we start with the first table that needs to be joined together. We have albums and artists that are joined by that artist ID to artists.id relationship. So I'll say from albums, that's the first table. And I want to add to the artist table now. So I'll say join artists. And now SQL wants to know, like, well, how are they joined together, right? Because if I just said from albums join artists, it's not going to be able to join them together in a sensible way, right? I think this might actually be valid SQL. Look at the title of the album. It's definitely showing us every artist name, but it's just repeating the first album name over and over and over. Because we've told it, like, to select stuff from albums join artist, and it's like, okay, I have an album title, but then since artist is like the last thing that it said, it's the last thing that it's thought about each of. So it's like holding on to this memo of like the first album title and just kind of like copy pasting it into every artist as it goes through them. That's not what we wanted though. We didn't just want any album to apply to any artist. We want to say specifically what we're joining on.
Did it apply all the artists to every single album? It looks like?
It's very possible. For Those About to Rock, yep. And then Restless and Wild, yep. And then Let There Be Rock, and then Big Ones, and then Jack, yeah. So every single artist gets every single album. So they were joined together, right? We made every single possible permutation of connecting an artist to an album. Yeah, that's too much, right? We don't need that many. We can make it more specific and say, let's join it on a certain condition, right? And the condition that we're joining on was, once again, when we were browsing our artists, we noticed that they had an ID that would correspond to the foreign key on a given album of artist ID. So we list both of those table field names. So we have albums.artist ID, and on we'll use a single equal sign as its operator for checking. It's not like a double equality like in Ruby. They just use a single equal in SQL. Hey, that's probably what SQL is short for. Single equal, am I right? All right. On albums.artist ID equals artists.id. Let's see what this does.
Doesn't matter the order, like which one you flip first.
Yeah, let's try to flip it. This seems to be okay, by the way. Jagged Little Pill is associated with Alanis. Facelift is Alice in Chains. Down here, Garage Inc. is Metallica. Greatest Hits is Queen. That's true. Queen did write the greatest hits. I'm just not aware. I'm the guy that only knows that Queen has greatest hits. Like, that's the only greatest hits album I've seen in my life. So, like the Eagles. Hey, they copied Queen. The Eagles stole all of Queen's best songs. Yeah, Deep Purple and Rock. Cool. So what if we flip this order? What if we said on artist ID equals albums artist ID? Is that going to flip the order? Are we going to see name and then title? Nope, same output. What if we wanted to flip the order of these two things? Where would we do that? Up top. The select is where we're like literally kind of making our layout. Select artist.name, comma, albums.title. Oops. I had a comma after albums.title still. There we go. So now it's the artist name followed by the album title. Cool. So that's essentially how a join works. Let's do another one. Let's try this. Yeah, if we flex this and say like inner join artists, we run this. It actually, if you look at the time that it takes to return, oops, I wrote join. There we go. I don't know, like it says that took 59 milliseconds, and if I run it again, it takes 56, and then 70, and then 57. That seems to like be around 60 or 55 milliseconds. If I say inner join, it seems to also take about the same amount of time, maybe a few milliseconds longer. But the difference between join and inner join is like what records SQL actually brings back. So if I was only requesting, if I'm going, basically there's different fields, right, than the ones that I'm joining on and the ones that I'm selecting for. And inner join versus outer join versus left join versus right join impacts which records, like which unjoined records are going to get brought back. So it's possible that you have records on the albums table that don't actually point to an active record in the artist table. And it's possible that you also have like artists that aren't pointed to by any given albums, and what type of join you use affects whether SQL brings those things back that aren't really part of our immediate concern. Those are more about optimizing like the speed at which you do stuff and the amount of records that you have for future queries if you're going to chain a lot of things together. But since we're about to use a tool that kind of optimizes how it does its own joining and stuff for us, we're going to mainly focus on like how to mimic the things that we will be configuring in the tool. But yeah, still a fun and fascinating thing to Google. It's just not going to be a super huge focus in our labs and curriculum. Yeah.
Is it default to inner join? Like if you just type join as a
I believe that's the default in how we do stuff. And I think that some other databases don't necessarily default to that. Like I've heard of left join as like being a default of just like the first thing that is mentioned does have like preference and more records from the first thing get brought back. In any case, the key piece here I think is about the on, that once we can find how the foreign key on one table points to the primary key of another table, whichever type of join we end up using, SQL is going to strive to make that connection between those two tables. So if we have more than two tables that are joined together through multiple foreign key primary keys, it's also possible to like chain this, right? I could say like inner join artist on this, then I could say like inner join some other table, others, right, on others dot album ID equals albums dot ID. And that way, if like an album had many others and an other belongs to an album, I could bring in like that to my realm too. And a lot of times when you're writing SQL, we do have to chain these things together. Chaining these things together can be more tedious than it feels like it's worth after you really grok the concept of the join and like you know how to match the keys. So a big part of today is going to be about figuring out how to do more of this work in an automated way and less of it having to type in all the SQL ourselves, but we are still trying to understand this SQL. So to that end, I will say that if you've been working on the main SQL labs, like up until now, and you haven't touched the table relations stuff, the table relations labs are crucial, I think, going into the afternoon, and they will also help you to understand the basics, like through osmosis, of all the stuff that the intro to SQL labs were talking about. So I would prefer and prioritize the table relations labs today, because I really think that the whole point of today is to be thinking about how these things join together and practicing like drawing those connections either physically on a whiteboard or mentally or through the syntax that we put in our code. If we wanted to display the artist name, album name, and number of tracks, let's close here. So this will include a third thing, right? We need the artist name, album name. We know that it's an album title. So artist name, album's title, from albums join artists on artist ID, album's artist ID. Okay, and what else can we bring in? We need tracks too. Now a track does know about an album. So let's try to join tracks to this. Tracks, I'm gonna reduce this syntax to like the most essential part. So I'm gonna take the inners out just for readability. Join tracks on, and the condition where a track connects up with everything else is that a track has an album ID and an album has an ID. So on tracks dot album ID equals albums dot ID. And now we need to get our count of tracks. So how do we get a count of something? SQLite. There's a count function. Great. Count items in a group. Count all distinct an expression. Okay, let's see an example here. Select count of something from a table. So we can say in like parentheses like star of like count for whatever, or we can like specify a field that we're counting. But count of star from a given table. Okay, let's try that. Select count. Yeah, well, we already have table stuff, right? From artists, albums, tracks. So let's say count of maybe like the track IDs. Tracks.id. Because then it'll count that attribute like right off of that table. And how many tracks do we actually have like total? I don't even know. Tracks. Wow, we have like 3,500 tracks. But each of these albums should probably be like what, like 8 to 15 tracks, probably. Rock albums tend to top out around like 9 to 12 tracks. Let's see if this works. Let's see what this gives us. We want an artist name, an album's title. Ooh, I forgot a comma after title. And then a count of tracks ID from albums, which we're joining to artists because the artist ID is linked to the foreign key on album. And it's also joined to tracks because the foreign key on tracks is linked to the album. And we'll hit play on this. Oh dear. So something's missing here, right? Here's that number, 3495, right? It knows that we have a track count of 3495, but it just counted all the track IDs and then said, here's our count of tracks. There's only one count of tracks, therefore I only need to give you one artist to album grouping. So I really want more than one artist to album grouping, right? I want to really have per each of those, I just want to see that chunk of tracks. I don't really want to see an overall count, right? I want to see a count that is grouped under the context of one album, right? So let's try this. At the very end of our query, we can add a group by, and then we can say, let's group this by albums.id. Because I want a scope of like how many tracks per album. So if I'm going to count tracks, I would like to have those counts of tracks batched up according to the album ID on a given row that we're talking about. Let's try this out. That's a lot better. Now we actually have counts for like what's on a given album. Count tracks ID, got 5, 7, 10. So generally when you're doing like some kind of a count, it's gonna need some kind of a group by as long as you're returning like more than one row of information, because otherwise SQL will come up with the overall count of those IDs in the entire table, and then that number of counts that it did, which is just one, is gonna equal the number of outputs. So if we want a number of outputs equal to the number of albums that we're listing, then I should group by some attribute on albums. What if I grouped by artist ID? I feel like this would be like showing us all the album names maybe, but maybe a higher number, because like it might show all of the tracks that were written by a whole artist next to their albums, and then the same artist, like AC/DC, like this is 10 tracks and 8 tracks. Maybe if AC/DC wrote 18 tracks total, we'd see like 18, because the count might be scoped to the artist instead of the album. I don't know. Let's see. Ooh, 18, 15, wait, where'd the other AC/DC go? AC/DC, Those About to Rock. Yeah, look, we don't have any other album name now. We just have one artist, the name of the first album that's in the list, and the total number of tracks. The 10-track album and the 8-track album get collapsed into one row because we scoped by the artist. But if we scope by the album, then they get separated into 2 albums. That's kind of cool. So I think that the count and the group by thing is more of like a sideline curiosity for this one query. I think the really cool stuff happened when we were like, oh, we already had this thing that was joining artists to albums. Let's tack on this thing where we just add tracks to the mix, right? Because if that's true, like we should be able to see the genre, right, of these like tracks potentially. like, or at least the genre of track 1 maybe, if we wanted to like add like genres.name. Is it a name for a genre? I don't know. Genre. Yeah, it's got a name. And so then if we wanted to add a genre's name, this is going to have a problem, right? Because it says no such column genres.name, because genres table isn't part of the tables that we're looking through. So in between this last join, we could tack on another one, join genres. That's a good name for like a drama actor. I'm join genres. And we could join genres on a track having a given genre ID. Tracks.genre ID points to a genre's ID. Oops, let's try this out. What is my, I have a syntax error. It just really doesn't like this syntax at all. Select artist.name, albums.title, genres.name. Did I say genre.id? I sure did. It's genres.id. The error told me the problem, no such column genre.id. But the problem is here with SQL, like it said at line 1, because this whole thing is like one line, it's just one query. So sometimes you really do have to read through every instance of where you wrote a word when you look at an error in SQL, but that was the problem. Look at this, AC/DC, for those about to rock, rock, cool. So like even if there was probably mixed genres on some of these albums, so what I think is probably happening is since we're grouping by albums.id right now, like we're not seeing specific track genres, right? But if we grouped this by tracks.id now, I think then we'd start seeing the album name repeated, right? But now each track gets its own genre. Yeah, now we have For Those About to Rock, We Salute You. And we don't actually have the track name showing here, so we could show that. Maybe instead of the count of tracks ID now, we'll still do that. Count of tracks ID, tracks dot name. There's our count, there's the track name, and the genre for the name. You could also, I think, say something like this, genres.name as genre name. I think this is a thing I'm allowed to do. Yeah, notice I've renamed the column of the output because they both said name before and I didn't like that because I wanted to know which one was the track name and which one was the genre name, especially if I'm about to listen to like an Andrew WK album where like 6 tracks are just called the word rock, something like that. Yeah. Yeah, I think it's very possible to just say count of everything that we have. But if I wanted to be specific of like why I had that count there, right, that might be a reason to pop it in. But yeah, it still works the same way either way. So yeah, that as is a nice piece. The idea here is that we have multiple tables, right? And we can see linkages between these tables. Because of these foreign keys, which are always like have the other table name that we're linking to underscore ID, a foreign key is going to have that name by convention, right? So if a cat belongs to an owner, cat's table, those fields are going to include owner underscore ID, right? If a floor belongs in a given building, then the floor is going to have building ID. The room is going to have floor ID. The table is going to have room ID. The chair on the table is going to probably have chair ID, right? Table has many chairs, room has many tables, etc. So that foreign key to primary key relationship is what we kind of lean on when we do our joins. We say from the first table, join the second, and then we say on, condition using an equal sign that links the first table up with the second. If you use the wrong on condition, you'll get joinage, right? But it's probably going to be weird, right? If we flipped these around and like one of these was joining to a genre ID instead of an album ID in the wrong place, then we'd have weird linkages because the connections wouldn't be what we anticipate. So it's on us to make sure that with our eyeballs, we can first browse our data and see, oh yeah, this track has a genre ID. So let's see, Restless and Wild, let's see, which of these songs do I know the genre by the name? I don't know, Walk on Water? Yeah, that's by Steven Tyler. So that's probably gonna be, yeah, Love in an Elevator. I know that for sure is a rock song. So I see these songs with like 1 as the genre. I feel like the genre 1 is gonna be rock. And genre 1 is rock, right? I think that using a tool like this DB browser is really important today, especially like for this next hour, just to make sure that we with our eyeballs can like browse through data and point at a foreign key and then go and find the primary key in the other table ourselves. If I can't do it as a human, I can't anticipate how a computer is going to do it, and I can't adjust my instructions to that computer when it stops doing what I want it to do. So this exercise of like moving from table to table, visually tracking and making sure that you can anticipate what you're going to see on the other end of the rainbow when you follow a foreign key home, I think that's the main skill to work on this morning. This afternoon, we're going to come back to this same domain, but I'm going to try to create Ruby classes that can be used to retrieve this same information. I want to take this SQL out of the browser and start putting it back in our Ruby code so we can get right back into Ruby ASAP. So that means that this morning, I want everybody working hard on these table relations and making sure that they can internalize as much of those joins as possible before we get back from lunch and start talking about the next stuff. Yeah.
One of the things I was running into is when we were doing this, we got everything to join correctly, but couldn't pull out an individual value. Like I want all the values that associate to like artist name, Black Eyed Peas. I couldn't get it to do it.
So if we just wanted these joins like where there was a certain condition, I believe the where is going to come after the joins but before the group by. So if I only want to know where the artist name is like AC/DC, I might pop it here. Where artists dot name. If I just said name equals here, there would be a problem because it's not going to know which table because there's multiple tables that have a name field. So I'm going to try this way. AC. Actually, we could also try this. Artist name like. This is like a case insensitive equals AC/DC. This is the unplugged version of AC/DC. There it is. Now we're just seeing tracks listed by AC/DC.
When I tried to do a where artist, when I tried to do that where I did like where artist dot name equals, I did like Black Eyed Peas, but I typed it exactly as they had it in the table.
Interesting.
And it just was giving me like 0 results.
That's weird. On mine, let's see, Black Eyed. Oh, I have a lowercase e. Let's try this. No results. Let's look at the browse data. Artist name was artist 169. Did they spell it wrong in the database? I wonder if I did ID equals 169 if it would be the same. Black space I'd space P's. Let's try artist ID as 169 because we know that worked before. And another reason for like IDs being great is that like it's very hard to mistype a number when you know the numerical value. Sure, so 0 rows returned. So this would tell me that there are 0 albums with the artist ID of 169, right? Because like otherwise,
our artist table just has no Black Eyed
yeah,
Peas
maybe there's
albums.
no Black Eyed Peas albums. Let me actually run this back one step. Yeah, that's the one I want to preserve because it uses the most of the things. And more. All right, cool. So we'll go back here. Artist ID. Yeah, let's make some. So if I'm not sure, right, now we can use the things that we've learned to interrogate our database. So I'm going to look for all of the albums where the artist ID is 169. And oh, by the way, the all caps text is like optional just for readability for humans to tell the keywords from the table names, but you don't need them. Select star from albums where artist ID equals 169. There are none. Result, 0 rows returned. Yeah, there's just no albums that belong to the Black Eyed Peas.
So it's like where it was right.
It's a shame. Yeah, I had a feeling that search was going to be a good search. I guess not. I think that's a clue that it's time to get it started. Yeah? All right, thanks, y'all.